This is section 6.1, problem numbers 1 and 2. Number 1 says, which, if any of the curves in the figure below look like a normal curve? If a curve is not normal, tell why. All right, so we've got this, 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 and this. Okay. Well, let's see what we can do here. What about A? Does A look normal to you? I'm going to say no because this is called skewing. It's skewed to the left. So what do we do here? We select, I guess I can't do it there. Anyway, I select, okay, how am I going to do this? I'm just going to say no. Skewed left. And what about B? B, all right, B is this one here. Well, that's not going to work because it drops below the horizontal axis. So let's say no, drops below, I don't know if it's the X, I'll call it the horizontal axis. And what about C? Well, a normal curve, we're looking for something that looks like this. Well, sort of. Okay, more like that. This has got a couple of bumps in it here. I'm going to say no. It's not really a bell-shaped. Not bell-shaped. And then what about this one here, D? Okay, well, that's not bell-shaped, right? That's it's not even smooth for that matter. So let's say no, not smooth. Okay, well, it looks like none of them resemble a normal curve. Problem 2 says, what percentage of the area under the normal curve lies to the left of the mean? Well, it's symmetric, so you've got 50% to the left, 50% to the right. So what percent? I'm going to say it's 50%. Now, part B. What percentage of the area under the normal curve lies between mu minus sigma and mu plus sigma? We're going to need to know the empirical rule here. Let me grab that. So I just pasted in the empirical rule. Now, the empirical rule says this, right? Here's the mean. Right, here's the mean. If you go one standard deviation, now apparently this is one standard deviation. So if you go one standard deviation to the left, you're at the mean minus one standard deviation. Over here, you're at the mean plus one standard deviation. Now, what do we want in this problem? Down here, it says, what percent of the area lies between mu minus sigma, right there, and mu plus sigma? Well, how about that 68%? So we'll go with that. We'll go with 68%. And the next part, C, what percent of the area under the curve lies between mu minus 3 sigma, mu plus 3 sigma? All right, so you find mu, there's the mean. You go 1, 2, 3 standard deviations. Mu minus 3 standard deviations. And there's the mean. Mu 1 standard deviation, 2, and 3. There's the mean plus 3 standard deviations. So how much area is here? 99.7%. So if you're dealing with a normal standard, a population that has normal distribution, if you go out 3 standard deviations in both directions, you've got almost all of the data.